So today we're going to be using logs to solve exponential functions. Now we've solved exponential functions before. You don't need to write this, but I just want to remind you of what we did. An exponential function is something that looks like this. And what we did to solve these was we got the bases to match. And once we got the bases to match, we crossed this off, and that was our answer. Okay. Well, there's some situations where that's not possible. So, for instance, if I gave you this, you can't get those bases to match. And for those, we're going to be using logarithms to do it. Okay. So that's one of the useful things about logs. Is they can help us solve things that we weren't able to do before. So let's begin here. This is example 1. So go ahead and write down example 1 there. And if you've got to class a little bit later today, we are going to be needing calculators, so you might want to have one. So you guys might remember this. This was property 3 from one of our early lessons, like 9.3 or 4 or something like that. I forget. But we had a property that looked like this. Actually, I'm thinking of a different property. Actually, what we call property C. It looked like this. When we had that, what we could do is we could take that power and we could move it to the front of the log like that. We called it property C. Okay, and we're going to be using that property today to solve these equations. We're also going to be using the change of base. All right, so here we go. I'm just going to rewrite it so I have some space here. All right, so the first step is to log both sides. Okay, and we're just going to use base 10. Okay, so I'm going to log this side, and then I'm going to log this side. Then we're going to use property C. Property C says I could take this A and throw it into the front as a multiple. Instead of a power, now it's a multiple. So step 1 is to log both sides. Step 2 is to apply property C. All right. The next step is we're going to divide both sides by the log that's next to the letter. That way, if I divide this, these cancel each other out. And whatever you do to one side, of course, you do to the other. So we divide. I'll just put a division symbol there. And that leaves us with this. A equals log 58.6 over log 5. And this is where we put stuff into our calculator. Okay. When you do this, don't forget that this needs its own set of parentheses. And so does that. So if you want to practice typing it in, you can. I'm going to type it in as well. I'm getting 2.529. I like to usually go to the third number after the decimal. You don't really necessarily have to. Just make sure you follow the instructions. If the instructions say to go to a certain number, just go to that. But otherwise, I just go to the third number after the decimal. But there you go. Now, so let's review what we did here. This is an exponential function. In the past, we solved these by getting the bases to match, but that's impossible here. You can't do that. So instead, we're using logs. Step 1 is to log both sides. Step 2 is to use property C to move that variable to the front as a multiple, which allows us to divide so that we get the A by itself, and now we have the A value. It's 2.529, all right? So that is the idea there. Why don't you, I wonder, let me see, how many of these? Okay, so let's do one with an E. It's not that different, honestly, but let's do one with an E in it. So go ahead and write down number 2. Okay, so Robin, what's our first step? Log both sides. And notice I'm using base 10. I'm just doing a regular log. Technically, you could do any log you want to, but the reason we're using base 10 is because that button's on our calculator. All right, so step 1 is to log both sides. Owen, what's the next step? Yep. Property C says I could take the A and multiply it to the front of the log instead. DeAndre, what's next? Oh, Dion. Oh, sorry. I was thinking Damien. Sorry, DeAndre's not here. Brianne. What's next? Divide. And so we have this. Now the trick here is finding the E button. I'll help you guys out with that. All right. So if you guys need help finding the E button, I'll show you where it is. Go ahead and type all this in first into your calculator. And when you get here, I'll show you where the E is. So go ahead and get up to that point, and I'll show you where the E is. So to get the E, you're going to push the top left button here that says second on your calculator. And then you're going to come over here to where the division symbol is. Above that, you see the letter E there. So if you push that, so second and then the division button there, it'll give you the E. And that's good to go. So at that point, we should be able to push equals and get an answer. Let's see. Did you guys get 3.664? That would be the answer there. All right, so I'll put up 2 for you guys to mess around with there. All right, try those 2. All right, so let's go ahead and proceed. All right, so just a slightly more complicated problem here. Notice that this time we have more than just a letter here. It looks weird, but really the process is identical. So we still start off by, well, let me give you a second to write it. So go ahead and copy that down. We'll call this example 2, by the way. Go ahead and write that down. All right. Here we go. So step 1 is to log both sides. Same first step. Log both sides. Step 2 is the same. You're going to take the exponent, but this time you're going to take the whole thing, and you're going to put it in the front. And since it's a binomial, I'm going to put it in parentheses. You would probably still get the right answer even if you didn't do that, but I think it looks more mathematically appropriate. So step 1, log both sides. Step 2, move the power to the front. Same exact step. Last step is to divide. Notice that none of these steps are any different. They're all identical. It just looks a little more. This is where things do get a little different, but really not that much different. Usually at this point we just use our calculator and be done. We are still going to use our calculator, but we won't be done after that. So let's go ahead and do log 50 divided by log 10. Log 55, I mean, divided by log 10. Yep, 1.74, and I'll just stop there because the next one's a 0. So usually in the last part we would have been done here, but for this I still don't have x by itself, so I just need to do some basic algebra to get the x by itself now. So the first thing I would do is I would minus 3 on both sides. And feel free to use your calculator to do these, because usually you're going to have a weird number over here, like 1.74. So 1.74 minus 3 is negative 1.26 if I just round it to the thousandth place. And then we're going to divide by negative 7. Once again, I'm just going to use my calculator to do that division because that's a weird number, but I end up with 0.18. So everything was identical. Log both sides, move the power to the front, divide. It's just that after that you still have to solve for x by doing some basic algebra. Feel free to use your calculators because they will be some weird numbers. All right, I think it's your turn. So go ahead. I wonder. Yeah, go ahead and give that one a try. I'll pause there and let you guys try that one real quick. There you guys have it. So step 1 is to log both sides. Step 2, move the power to the front. Step 3, divide the log. Step 4, solve using your calculator. All right, so we're going to take it up a notch again. Let's move on to example 3. Go ahead and write that one. All right, so example 3. We're just kind of taking it up a level every time. So in this case, what I want you guys to notice is let's box this. You don't have to do that, but for your notes, it might be helpful. That part is the exponential piece, we'll call it. So I would just say, get rid of the outside numbers. Now this is kind of tricky because they're not really outside numbers. If I wrote it like this, there's no numbers outside of anything. There's just numbers, right? But what I want you guys to think of is think of this piece as a whole. And I box it in because everything else is what I'm going to call the outside numbers, okay? They're outside of the exponential piece. So I need to get rid of the 5.4 and I need to get rid of the 8. That's the first step. After that, the problem is exactly like the last one. So here we go. Step 1 is going to be you usually do any kind of adding or subtracting that's available first. So let's start off with adding 8 on both sides. I'm still going to keep this box. It doesn't have to be there, but I think it's helpful, so I'll put it there. So the number that's separated from the box by a plus or a minus, that's the one that you add or subtract. The one that's right next to the box with nothing in between, that's the one you're going to divide. So we're going to divide both sides here by 5.4. All right, 27.9 divided by 5.4. I'm getting 5.167 if I round it. So let's stop here and get a breath for a minute because that's all that's new. The rest of it's old. So what do? When you have a whole lot of extra numbers here, this piece, the number that has a power, think of that thing as a box. Anything outside of that, we get rid of. Stuff that has a minus between that and the box, or a plus, you're going to add or subtract it. Stuff that's right next to the box, you divide. From there, it's the same, nothing new. We're going to log both sides. Now at this point I'm going to start showing a little bit less work. I'm going to do it like I did earlier. So basically I'm just going to cross this off and I'm going to move it to the front now. And then I'm going to cross this off and move it to the bottom over here. That way I don't have to keep writing the same thing over and over again. I wouldn't advise that at first. You want to see the steps at first, but once you get used to it, you can kind of start doing a little less showing on paper. Don't forget to put those things in parentheses. If you don't, you'll get the wrong answer. I'm getting 0.606. And now we need to solve for x by subtraction. And division. I'm getting negative 0.759 approximately. So from here down, all that over there is old stuff. This is the new stuff. Get rid of the outside numbers first and then just do what we did before. All right, so of course you guys get to try one like that before we move on to our next set. So let's throw one of them at you. Give that one a try. Okay. This is something we haven't seen for a couple of weeks now, but a while back we talked about continuous compounding. So you guys should circle that word there, continuously. When we learned about exponential functions, that word, I think we learned about 3 or 4 different exponential function formulas depending on the different types of word problems we were working with. For this one, when you saw the word continuously, it tells us to use this formula, okay, where y represents the final amount, p represents the starting amount, r, and I should put a plus or, well, let's see. Yeah, I guess we'll put a plus or a minus. R is the percentage, but you got to remember we divide it by 100 to change it into a decimal. If it's positive, that means your amount is increasing. If it's negative, that means your amount is decreasing. And then t is usually some kind of time. So I'll let you guys write that because you'll need to know that stuff for these problems. So a savings account balance is compounded continuously. The interest rate is 3% per year. The current balance is $1,661. How many years will the balance reach $2,049.14? So this here, the one that's a percentage, that is our R value if we divide it by 100, which is 0.03. So that's my R value. Remember, when you have a percentage, you have to move the decimal over twice. In other words, divide it by 100 when you use these formulas. This is the starting amount of money that we have, so that will be the P value. This is the ending amount of money, so this is the Y value. The thing that we don't know is the T, how long, because that's what they're asking, and how many years. So we need to figure out what t is. So we're going to plug in the y, we're going to plug in the p, we're going to plug in the r, and we're going to solve for t. Okay? So here we go. We have 2049.14 is the y value. The p value is 1661. Then we have an e. And then we have our r value. And then we have our t value right next to that. So we have an account where we put this much money in it. We want to know how long will it take to reach this much if it's being compounded continuously at 3%. So let's find the answer. So this is the piece I want to get by itself. So what would I do first to get the e to the 0.03t by itself? How would I get rid of that 1661? If there was a plus here, I would agree with you. We're going to divide both sides, yeah. So let's start off with division here. Get 1.23. Now what do we do? We're going to log both sides. So at this point, you guys are seeing there's nothing different from what we learned the rest of the day here, right? So really the only part that's different is keep setting up the equation yourself. After you've got the equation set up, we're just going to follow the steps that we learned today. The next step is to take this guy and throw it up to the front. Then we're going to divide both sides by log e. I think I'm going to stop there, though, after this because we're running out of time here. So I'll let you guys go ahead. You guys can start packing up now if you want to. But I think you guys should be able to handle it from there anyway. Nothing new is happening at this point. Don't forget to put those calculators back before you go. And that'll be it. So we will see you guys tomorrow. I'll let you know where you're going tomorrow because tomorrow is the PSAT day for juniors, and many of you guys are